An ancient bamboo fan rests quietly on a wooden porch, bathed in the late afternoon sun. The natural wind whispers through the slats, creating a dry and rhythmic clicking sound. Dusty carvings of feather fans on ancient stone walls tell a story of time long past. Massive wooden gears of a primitive cooling system begin their heavy, labored rotation. A hand in a classic suit carefully sketches technical diagrams with a traditional brush. Fingers touch the engraved year 1882 on a small brass plate of an antique machine. Gloved hands adjust the copper bars on the world's very first electric fan. The cast iron blades nudge forward, producing a powerful and distinct mechanical hiss. Yellow light from a filament bulb casts the rotating shadow of the blades against an old brick wall. Small electric sparks fly from the commutator of an early generation motor. Old film footage captures a group of people gathering around a fan on a sweltering summer day. A slow-motion breeze scatters papers across an old desk, signaling a new era of comfort. Through the art of morphing, an ancient iron fan transforms into a sleek, modern frame. A scientist watches the movement of the blades in the lab with intense focus. Sunlight streams through large glass windows into a modern, uncomfortably hot room. A finger gently touches a touch-sensitive button, and a cool green signal light flickers on. The modern blades begin to spin smoothly, bringing a deep silence to the space. A thin silk curtain dances gently in the breeze that spreads throughout the room. From high above, the modern factory glows brilliantly in the first light of dawn. The camera rushes through the factory gates, entering the heart of the production line. Thousands of pure white ABS plastic beads pour into the hopper like a cascading waterfall. The needle on the pressure gauge moves steadily toward the optimal processing temperature. The injection screw rotates, pushing molten plastic into a massive steel mold system. The steel mold slams shut with hundreds of tons of force as steam rises from the gaps. A robot lifts out a newly formed plastic fan blade, shining and perfect. Cold air blasts the blades on an automated conveyor to cool them rapidly. An automated blade decisively trims the excess plastic from the center of the fan. Newly molded fan bodies stand in long rows, passing through a high-precision laser inspection. A massive raw steel coil is pulled straight at incredible speed by the uncoiling machine. The stamping press cuts the steel into circular shapes for the protective guard with powerful thrusts. Small steel ribs are fed into a circular mold in a perfect concentric geometric pattern. Spot welding machines release a shower of bright orange sparks to secure the fan ribs. The welded fan guards are hung by robots onto a mobile overhead conveyor system. The guards are dipped into a chemical bath to thoroughly clean all metallic impurities. In the electrostatic spray booth, nozzles coat the guards in a fine, mist-like layer of paint. Infrared lights inside the drying oven glow intensely, curing the paint in a matter of moments. The surface of the fan guard is now smooth, glossy, and completely flawless. Mechanical compression equipment tests the hardness and durability of the fan ribs. The fan base is molded with a heavy metal core to provide maximum stability. Small plastic components and buttons are automatically sorted into their own specific trays. A robot laser prints the production serial number onto the inner surface of the plastic body. Specialized white silicone grease is applied to the plastic rotating joints for smooth movement. Trays of finished components are gathered at the central assembly area by robotic carriers. A wide shot reveals the entire component workshop operating like a single giant machine. The camera moves swiftly along the power lines toward the motor manufacturing section. Coils of bright red copper wire shimmer under the factory's brilliant LED lights. High-speed winding machines spin the copper threads thousands of times around the steel core. The needle of the winding machine moves with extreme speed in a complex circular path. Skilled workers carefully insert white insulating paper into the slots of the stator core. The stator is fully submerged in a blue varnish bath to create a protective coating. CNC machines process the steel rotor shaft as small metal shavings fly off continuously. The cutting tool polishes the surface of the steel shaft to a perfect mirror finish. Bearings are pressed onto both ends of the rotor shaft using high-pressure hydraulic machines. Permanent lubricating oil is injected into the bearings to ensure long-term silent operation. A mechanical arm places the rotor into the stator with absolute precision down to the micron. The aluminum housing is assembled, with the cooling fins aligned in perfect rows. A robot performs electronic welds to connect the power leads to the starting capacitor. During the first power test, the motor spins up rapidly to reach its maximum speed. An oscilloscope screen displays a stable electrical wave, free from any interference. An infrared temperature scanner sweeps over the motor casing to check heat dissipation levels. A laser gun measures the rotation speed as the RPM figures appear on a digital screen. Highly sensitive sensors placed on the test bench measure any vibrations in the engine. The motors are passed through a degaussing chamber to prevent them from attracting dust. Serial numbers are laser etched onto the motor housing for strict quality management. A wide view shows hundreds of motors undergoing continuous operational testing. A 3D cross-section animation reveals the powerful swirling magnetic fields inside the motor. An engineer measures the gaps between components using ultra-thin feeler gauges. A single drop of oil falls onto the motor shaft in extreme slow motion. The finished motors are neatly packed into protective foam boxes for the final stage. The camera follows the conveyor belt as the motors move toward the final assembly area. The final assembly line glows under modern white lights, ready for the finished product. The motor is attached to the fan neck joint using high-speed automated electric screwdrivers. A smart control board is installed precisely into the front housing of the fan body. The power cord is neatly threaded through the body and down into the plastic base. The rear protective guard is attached to the motor flange and secured with a locking nut. The plastic fan blade is pushed onto the steel shaft, clicking into a perfect fit. The blade cap is tightened counterclockwise to ensure a secure and safe attachment. The front guard is installed as a robot tightens the locking ring around the perimeter. The completed fan is placed on a test bench to perform a full 360-degree rotation. Noise meters display record low levels, even when the fan is running at maximum speed. The oscillation feature is tested repeatedly to ensure the mechanical durability of the unit. A high-velocity wind simulator blows directly at the fan to test its base stability. High-voltage discharge tests are conducted to verify electrical insulation and user safety. Industrial ionized air guns blast away any remaining dust from the finished product. Quality certification and warranty labels are applied to the body of the fan. Manuals and warranty cards are tucked into clean plastic bags for the customer. A machine automatically opens the cardboard cartons as shock-absorbing foam is placed inside. A robotic suction arm lifts the fan and gently lowers it into the packaging box. The sealing machine tapes the boxes shut with consistent speed and precision. Pallets of goods are stacked and wrapped securely in protective stretch film. Electric forklifts move the pallets into a high-rise automated warehouse system. Barcodes on every box are scanned before the products leave the factory floor. Container trucks wait at the warehouse doors as the factory lights shine through the night. The container wheels begin to turn, carrying the products away from the factory. A small family gathers in the living room as a gentle breeze lifts the edges of their clothes. A baby sleeps peacefully in a cradle, with the fan running silently nearby. The fan operates alongside solar-powered devices, representing a sustainable future. A young engineer wearing VR glasses adjusts a futuristic fan model in virtual space. A simulation shows the fan identifying the user's position to direct the airflow. A minimalist fan design is placed within a modern architectural space filled with light. The breeze sways fresh flowers, symbolizing a breath of clean and pure air. Proud faces of the factory workers are illuminated by the light of a new sunrise. A craftsman's hand gently strokes the smooth surface of the finished masterpiece. An image of a green earth is surrounded by refreshing and cooling currents of air. The ancient bamboo fan reappears, fading slowly into the silhouette of the new technology. The camera zooms into the center of the spinning blades, creating a brilliant circle of light. A radiant glow radiates from the center, covering the entire screen in warmth. The brand logo emerges solemnly amidst that pure and brilliant light. The screen fades to black as the final sound of a gentle breeze whispers away.